Hello, my name is Pranav Ahuja, and this is my ECE570 project presentation on automated machine learning with hyperparameter optimization using AutoML. So for my project, my motivation was for me to understand the foundational mechanisms of AutoML and hyperparameters that auto machine learning selected for this model. I wanted to learn the hyperparameters that were selected and what would happen by changing them to another search case. Now, if you don't already know, automated machine learning simplifies the tasks that users do not have to do. And one of these tasks is initializing the hyperparameters that are used within the model. AutoML automatically selects the hyperparameters that it believes are best suited for the model. But are they truly? In my implementation, I tune hyperparameters and compare my results with the results of the default AutoKRAS model with image classification, and I see how they differ and how they are similar. So I start off my implementation by downloading a TensorFlow Flower image dataset, and I split that into a training and testing sub-dataset with a split of 20%. First, I use the default AutoKRAS auto-selected hyperparameters to run my code, and to visualize the AutoKRAS's accuracy and loss for training and testing. And I get a sense of how my output should differ. I then start tuning three key hyperparameters. The first hyperparameter is a learning rate schedule, which controls the model's learning speed. The second hyperparameter is a number of blocks, which impacts the model's complexity. And the third and last hyperparameter is a number of layers, which determines the model's depth. I tune these hyperparameters by using Alpuna, which is an existing external hyperparameter optimization framework. And my key objective and my goal of my implementation was to evaluate the impact of hyperparameters tuning on the accuracy and losses for both the training and testing datasets. So after I obtained my results, I observed that it led to a very minimal improvement within the accuracy and losses. And actually, it was quite similar to the original. There was some additional loss within my models, but it wasn't that different from the original model of AutoKRAS. So here are the graphs, as you can see here. So first off on the accuracy. So both the training accuracies start to plateau at 1.0, indicating that the model is fitting the data well for both of them. The AutoKRAS's validation accuracy shows more variance and a slight downward trend after peaking on the second epoch, which may indicate some kind of overfitting. On the other hand, for the Alpuna model, the validation accuracy is more stable and it after reaches its plateau, which could imply that it generalizes its model better. Now for the losses, the training loss for both AutoKRAS and Alpuna are nearly identical. However, from my Alpuna training loss, the value is less than the AutoKRAS loss. So my model does have a better way for the training losses to manage. However, for the validation losses, my validation loss for Alpuna has more variance compared to the AutoKRAS validation loss, which may indicate that my model has more overfitting for the validation losses. Now for limitations, I had two main limitations. The first one was that I only tuned 3 hyperparameters. For a better optimization and performance gain, I may need more extensive tuning for hyperparameters to visualize a better gain. Also, due to compute constraints, I had a low number of epochs and trials because the deadline was coming up and there was not much time for me to compile my code. Now, the key takeaways is that AutoML does simplify usage, but does the automated selection hyperparameter select the best? I do not believe so. I think that integrating auto machine learning and optimization frameworks such as Alpuna may lead to better model generation. Also, we do need more extensive tuning for performance gains, as that could result from better optimization for our model. And if we can overcome our limited compute resources, we can have a better experiment with better performance gains and better optimization for our model. Thank you. Thank you for your time.